Alright, now we're going to go over an example of Charles' law. And so what we have here, we have an expandable container, in this case a cylinder filled with air, and we are going to see what happens when we change the temperature of that container. And so what happens to the volume of air in the container. So if we look at our formula sheet, we can see that Charles' law is equal to the volume of condition 1 over the condition, or the temperature of condition 1 is equal to the volume of condition 2 times the temperature at condition 2. And so here we have two conditions. We have the water, the cylinder in water, cold water. This is going to be 32 degrees Fahrenheit. So I'm going to just write that right here. So our water is 32 degrees Fahrenheit. We have we're going to warm that cylinder up, and so over here we have a temperature of 200 degrees Fahrenheit. The cylinder here, when it's at 32 degrees Fahrenheit, has a volume, so I'm going to call that V1, of 28 cubic inches. And over here we're going to see what happens when we heat that cylinder up from 32 degrees to 200 degrees. And so over here this is temperature 1 and this is temperature 2. Alright, so the first thing that we have to do in using Charles's law is convert our temperatures to absolute temperature. And so I'm going to do that right here. Absolute temperature is equal to the degrees Fahrenheit, 32 degrees Fahrenheit, plus 460 degrees. And so that gives us an absolute temperature for T1. I'll go ahead and put that. T1 should be 460 degrees. Of 492 degrees, and the unit is Rankine. Absolute temperature is degrees Rankine. Alright, so temperature 2 is equal to 200 degrees Fahrenheit plus 460 degrees excuse me, and we get 660 degrees Rankine. Okay. Alright, so the next thing we have to do is just plug in our numbers. So our formula for Charles' law is the volume of 1 over the temperature of 1 is equal to the volume of 2 over the temperature of condition 2. Alright, so the volume of 1 is 28 inches cubed. Put that over the temperature of 1, which was 32 degrees Fahrenheit. That's equal to the volume of 2, which we do not know, we're trying to solve for. The volume of 2 over the temperature of 2. You see what I did? I made the mistake there. We need to use the degrees Rankine, so it should be 492 degrees Rankine, and this number should be 660 degrees Rankine. For the formula to work, you have to have the temperature in that unit. Okay, so the next thing we'll do is just simply solve, and so we'll solve for V2. So the volume of 2 is equal to 660 degrees Rankine times 28 cubic inches divided by 492 degrees Rankine. Plug it in on your calculator. 660 times 28 divided by 492, and we get 37.5 or 37.6. We're left with, these cancel each other out, inches cubed. And so when we heated that up, the volume rose to 37.6 inches cubed. You can think of this, if you've ever messed with a gas tank for a lawnmower or something, you know, in the summer it expands in the heat. And so that's what's happening here. The volume of that air in the container is increasing with temperature change.